This is part 2 of the video regarding making a detailed drawing of one of 24. Our part 1 was creating a title block that was customized and slender and out of the way. That was part 1. That's a different video. This video is going to be focused on creating the detailed drawing itself. To the right, you see the image that we have. We're inspecting the cube. We remember that this image, the front view, is on this position. The top view is up here, and the right side view is over here on the right side. This is an inch drawing, so using third angle projection will be the standard that we use here. I'm trying to write that on the screen here using my mouse. It's going to be third angle, which means you're going to have your front view here, your top view here. This is traditional views, not necessarily this particular drawing, and your right view over here. In this case, we're actually going to slice this part in half based on the expectation of the customer. We need to do a half. We need to do what's called a full sectional view based on the assignment. So a full sectional view means you're going to slice the part literally in half. A quick reminder of what that means, if we jump over into Blackboard, if you wanted some reference information on that, when it comes to those types of drawings under the section, let me see if I've got it in here. I may not have the PDF in here as a reference for you. I don't. On sectional views, but a quick review on sectional views that I'll pull in from another class that I've got where this is actually covered. The engineering graphics class. In here, we do have an actual PowerPoint for the book that we use there related to this subject under the resources section. All on the subject of sectional views. So this is the book that I use in that class, and just a quick overview on sectional views shows you. This is a very good book as well. I like this book. Shows you that's what is what's called a full sectional view. You literally take the part and you're slicing it in half. Okay? I know the word half isn't what I just said. I use that word, but that doesn't mean it's called a half sectional view. It is called a full sectional view because I'm fully slicing it. All right? So a full sectional view looks like this. I slice it completely in half. This feature right here, where you see this line with the arrows, that's how you would show it in an ANSI drawing. This is a full sectional view. I've sliced it fully in half. What's missing in here is that this image, this section line is missing in here. But that's a full sectional view. Then there's something called a half sectional view, which is half of the full. Okay, you might think of it as a quarter because it's a quarter of the part that's being ripped out. But the term used is half. That's the term used. I'm not making this up. This is what industry uses. They'll call this a half sectional view. Then there's something called an offset sectional view. It's called offset because the line zigzags through the part. It's like if you took it to the machine and started cutting it up, you're cutting it at a zigzag kind of way. And the reason you're doing that is because you want to make sure you hit every element in the part. So that way the sectional view shows everything. That's just the standard. And then there's my favorite, and I say that with pure sarcasm, the aligned sectional view. Okay? An aligned sectional view, yeah, I have the same look when I think of this one. Yeah, I saw that look. This is probably the most visually confusing sectional view that I've ever had to deal with. On top of that, when you try to do this inside CAD, Inventor especially, or SolidWorks, or any of the parametric modeling ones, this is not something that you can do with any great ease. But I'll show you what you really get, which is a rotated sectional view, which is further down. Oh, not in this one. It's in a different PowerPoint. This one just covers some of the basics. The line sectional view, which is annoying because this one like rotates this hole up here. And so it gives you the impression there's two holes that are parallel to each other. No, they're not there. No, it's this thing. Broken out sectional views I've done before. Those are really cool, and they're used a lot in building design. So if I have a building and I want to rip out a corner of it so I could show you what's inside, this is how I would do it, and I have. I've done it for that purpose. This is another very confusing type of view that we don't use that much when it comes to parametric modeling, which is it's a revolved sectional view. We actually show the sectional where it came from, literally, in the object. It's very difficult to show this in CAD. AutoCAD, yes. Inventor, SolidWorks, good luck. Okay. Remove sectional views. These are sectional views that you relocate on the piece of paper somewhere else. They work, and this is not that difficult to do. Meaning I slice this out, and I'm only showing what I sliced through. I'm not showing anything behind it. It's like you took it and moved it somewhere else, and you don't show anything behind it. Those are very common. Here, conventional practice in a sectional view. Conventional practice is show that this is a rib. You don't slice through it. That's tough to do in a parametric CAD product. And then a sectional view of an assembly. Those are pretty neat to look at, and they look really good in parametric modeling. Computer-generated sectional views, they're much more, that's what you're going to be creating. And then another type of example of a sectional view, of a nozzle of some sort. I will go ahead and just save this as a reference for you. I'll post it onto Blackboard by you guys, just so you have it. Now, some of you are in the engineering graphics class anyway, so you should have access to it. But for those of you that don't, or you took it last semester, I just went ahead. I'll upload it for you guys in your class. So getting back to our class, how about I get to where I was? There it is, detail drawing. Let's minimize that. All right. So getting back to here, here's my drawing. I want to slice it fully, so it's a full sectional view. Here's the detail drawing, and now I'm going to bring in my base. My base comes from wherever my model is. So it's already there, so it's already staged, because my model's right here. Because here's my model. It was drawn correctly. When I go home, it's in the same orientation as this is, so everything is good. So the cube was respected, which is going to make my job over here 100. Did I just close out of my? No, I didn't. There it is. Right here, in my detail drawing. It's going to make my job here 100 times easier. Because there's my view. I got to pick the correct one because I have all three drawings open. And you'll see it right here. The scale, I'm going to change. Scale is something I've been starting to talk with in my other classes. And what I always say, start with 101. When we do parametric modeling, it's easy to do scale because you just switch it. So right now, right here is scale. There's my view. Okay, I'm going to drag it over here. I do see one little error we'll have to fix. And that's it. I just need, how many views do you think I need of this product? Let's throw a bunch of them in just for fun. I'm going to throw one up here, and then I'm going to put one over here, then I'm going to hit OK. Anyone notice any mistakes yet? The hole. So you'll notice we're going to ignore that for a few minutes. Just for fun, we're going to ignore it. And I say that because Anytime, let's say the customer wanted it there and then they changed their mind and they really want it centered, okay? That's the power of this product is keeping your detail drawing connected, fully synced with your model. That's the key. I don't want to mess around with this too much. Now, do you notice how the right side view and the top view, do they look the same to each other? Not exactly, because obviously the hole is in a different spot. The hidden lines are relocated. My answer to you is you don't need the top view. You only put in as many views as you need, no more. Now, of course, let me go ahead and fix the part. Now, if I didn't have my model open at the bottom already, I could actually right mouse button and open my model here. Then I can go to front view, and there I could see the holes in the wrong spot. I click on the hole, I right mouse button, and I want to edit the feature, meaning where is it located. Remember how the hole command worked? I got to maximize this to use my screen. Wherever your crosshairs are, see these things right here? Wherever your crosshairs are is where the center of your hole is. So wherever I move those crosshairs, boom, that's where my hole's going. Remember that. Because this was one of the first ones we did, so it makes sense that the hole was in the wrong spot because you were learning where to locate it back then. So we're going to save this part now. Now here's the cool part. When I go to the detail drawing, ta-da! It updates itself. The detail drawing updates itself. Now, for my file management masters in the room, which is all of you, please be mindful of the following. When you save this drawing for the first time, make sure to save it in the same place you're saving your other file. Word of advice, at least for this class. Okay? If you want to create a subfolder called detail drawings, because you have to, because that's how I think as well. Because you guys are me and I'm you. I know what it's like. And there you have part 1 of 24, and you hit save. Don't rename the file. Let me show you what people do that kind of messes things up for them. I'm going to jump out of Inventor real quick, and I'm going to go to that folder, which is right there. I'm going to move that back into its spot. I'm going to open this folder, and then I'm going to do the thing that I don't want you to do. I'm going to do the thing I don't want you to do. I'm going to turn around and rename my first file, just for fun. I'm going to call it Part 1. What's this called again? 1 of 24? Just going to say 1 of 24 model, just because, even though I know an IPT is a part file, just to do it, okay? Then that's it. I rename my model, okay? Now I'm going to go to detail drawing. I remember what I did. I created a detail drawing. I'm going to open up my detail drawing. Ooh, look what it asked me. Where am I going to open this up? Now, where do I want to open this up? Do I want to open it up as an Inventor file, or do I want to open it up as what? As an Inventor detail file or as an AutoCAD file? Where am I going to have the real control? Inventor. So I want to open it up in Inventor. So I open up Inventor. Let's see what happens. As soon as it opens, it looks like it's Windows 10, but it's not. It's going off to the network to download its license. So that's why it takes a little longer. So if I go to File and Open, and I go to where I'm saving this, which is Desktop, Gesundheit, Detail Drawing Part 1 of 24, and I hit Open, it's lost. You're going to get this message, Resolve Link. Remember, I renamed the file. When you rename the files, they lose their linkages because the detail drawing is searching for the file called Part 1 of 24. You renamed it, or I did. I want to rename it to something else. I renamed it to 1 of 24 underscore model. Well, when you do that, it loses that relationship. So you need to go hunt it down again. So whenever this message, this dialog box appears for you, first thing you have to ask yourself, which will be the first thing I ask you when you ask me about this dialog box, is, did I rename my file? Oh, yes, I did. Okay, so now I need to go select the new file name. And then I hit open and everything's good. Now this really happens when you do assemblies. Like you might name something a clip and then you realize, I got like 3 things that I want to call clip. I need to call this one clip A, clip B, clip C. That's kind of when that really happens. So when you do that kind of thing, you got to make sure to just reconnect everything. So there you go. And you're back in. No problem. Okay? Easy peasy. But you have to remember to do the file names. They're hot linked together. If you've ever been on a website where you see a little X, image not found, it's because they either removed the image or the file name changed and the software is still looking for that original file name and it can't find it because that file technically no longer exists. Remember, computers have like blinders on. You tell it to go look for one thing, that's all it will ever look for. It will never say, you know what, maybe that's not the nature of software. Okay, and to be honest, for those of you that would like computers to be Marvin the Mind Reader, you don't want that because then guess what? Marvin the Mind Reader doesn't need you. Okay, see the Terminator, what movies want to come up in your head of when the computers take over the world, okay? You don't want that. So back to this. Here's our 2 views. Now remember I said the view has to be a full sectional, right? Now, do I need to draw an additional view? Or can I be a little lazy? Because if I'm going to slice, let's do it. We're going to go to section, and it's this view. I'm going to use this as my primary view. Now here's something you do have to be patient with yourself on. Don't click. Because I know you're going to hit the middle and you're going to click, right? Because that's what we all do. You actually want to track off the part, click then, because this little line that I'm swinging back and forth is your knife. Your knife. Okay? And then you click through the part. And then you right mouse button. And then you continue. And then it'll say, what do you want to call the view? I'll call it AA. What scale would you, view A. What scale do you want it? Same as the original. That's fine, 1 and 1. When you hit OK, what kind of sectional? Full. Projected. Slice. It's sliced. You are slicing it, so it's okay. What kind of edge? That's fine. We'll leave it alone. When you hit OK, ooh, look what it did. It dropped a sectional view right there. Now, what's annoying is I basically have 2 views that look very similar to each other. I have this sectional view, and then I have this right side view. Do I need a right side view, guys? You got it. The answer is no. So I don't want to waste my time and have this view. Now, would you not have loved this in engineering graphics when you guys were doing this by hand? See how easy it is to add a view, take a view out, done. Figure out scale, didn't have to do any math, done. Isn't that beautiful? It is, but at the same time you have to understand where it's coming from, and that's where those hand drawings came in play. This is faster to do when you understand what the software is doing. Okay, other than it taking you for a ride and you're like, what the heck is going on? It looks good, but I don't know what it is. I don't want you to do that. So this sectional view looks okay except for a few things. What are some of the things that we don't like about it? The ribs. You see how the ribs are? So if you go in here, right mouse button and edit the view. Okay, this is, I'm sorry, right mouse button and edit, not the view, the section properties. Okay, so we've got a section. It's a full section. If we say include a slice, and we say slice the whole part, Projected, change it to, doesn't matter which edges. If I hit OK, then look what it did. Slice eliminates everything behind it, literally. Now that doesn't look any better. Okay. So do you have a fix? This sectional, if it was by itself, can mean one of two things. It could mean like the end of a pencil, where it's a full flute end with a hole in it, like a pencil. Looks like the end of a pencil. Or it can mean exactly what this is, which is a sectional view of something with ribs on it. In hand drawing, back in the day, that PowerPoint that I'd shown you, where you would have the sectional to identify this business, showing the sectional line, false impression of thickness, rib. See that? Even though a rib is cut, section lines do not appear in that area. Well, here's the rib is cut. Sorry, the section lines don't appear in that area, correct? And not if you're in parametric modeling. Yeah, it slices through the whole thing. Period. It is unaware that you have a rule somewhere that says that I don't do that. Okay? So the ultimate solution to that is to add a view. I'm going to click on a view. Whoa, I just double clicked on it, sorry. Click on a view, right mouse button, and you have the opportunity, let's see, we've got a projected view. So you're going to add an isometric view to this drawing. Now, creating an isometric view in hand drawings is a rather intense project, to be honest. For any of you who've ever tried to do it, it's involved. Here in parametric modeling, it's easy. Okay, so it's not a big deal. So what you would do is incorporate an isometric view. You would go ahead and the scale of an isometric view does not have to be the same scale as the rest of the drawing. This is the only exception to the rule. The views, and even a sectional view does not have to be the same scale as a primary view. But if I am going to use it as the right view or the top view or the front view in place of a view, it has to be the same scale. All right, guys? That's a general rule of thumb again. For me, that's how I do it. So your isometric, however, if I right mouse button on it, or even double click it, your isometric is the only one that you can manually tweak to whatever scale you want it to be. And then you can bring it in so that it's not in the fighting your drawing, but it's in there, meaning it's not trying to take ownership of your drawing. You can stick it in the corner there if that's a good spot. What you need to drop in are something called, I don't know, let me think. What are we missing, guys? The dimensions. We're missing center lines. Yeah, we're missing all the fun stuff. So when we drop in annotation, which is the second tab, I'm going to say use something called, let me think. I don't want to manually put in dimensions. I'll tell you that right now. You do not want to manually put in dimensions. You want to import all your dimensions. You've got chain, you've got ordinate, you've got baseline, you have dimension. It's missing something. What's missing? Import place views, annotate. In here, you don't have an option to import dimensions from the model. So you have to look down here. Maybe if I click on my, I don't want to do that. If you manually drop dimensions, it's work. You want them to drop in automatically. So if I go to right mouse button, and I have automated center lines, I have annotation visibility, I've got retrieve model annotations. Do you see that? If I click on the view out here and do right mouse button, Retrieve model annotations. Do you see that? Automated center lines is also extremely useful. So when I click on that, anything round, anything with a fillet, cylindrical features, see that? Revolved features. Pretty much if I pick everything, objects in view, everything. If I hit OK, didn't come in. Why? Did I just bring these views in, or are these views pre-existing? They're pre-existing. That's why. So up here is where I would draw the defaults. To be specific, come on you. It's there, but it's behind it, so I gotta drag them out. The other one I don't want, that's this one, but that's okay, I'll leave that in the middle. Over here, when I want to draw a center through this object, I pick this line, and I pick this line, and boom, there's its center. So the centers I have to put in manually. But how did I put in the dimensions? I forgot. Click on the view, over here for example. Hello, come on you. Hello. Hit escape. There we go. Click on the view, right mouse button. Retrieve model annotations. When I do that, look what it does. It drops everything in, wherever it is. Now, which view were those dimensions originally created in? If I hit apply, do I want them in this view? How about this view? Ooh. Which view do you think those dimensions were originally created in? Yeah, the right side view. That's why they appear so beautifully there. All right, so you've got this dimension and this dimension. Beautiful. We hit apply, they stay. In this view, if I hit select the parts and I just pick, actually it's in the middle of finishing that one. Here are the dimensions that it has. This guy, I have this, but notice how it presented that. Why did it do that? Where was that original dimension? Over here. Where was this original dimension? Over in this view. This guy, I don't know what this is. What is this? Is this the width of it? You did it from center, didn't you? When you built it? Extrude center plane? I'll find out. Because that's what this means to me. When I see a dimension like this, yeah, that's typically what, well, we'll find out. Let's find out. How you build your model totally affects what your detailed drawing looks like. I had commented on this in the past, but you don't really want to experience this until now. So when I roll this up, there's a sketch, roll this down, there's your base revolve. If I edit the sketch, there it is. See? That's where they were built. See? That's why they appeared where they want to appear. Now if I go to extrude, that's good. That's this guy. I bet it's extrude midplane, which is fine. There's nothing wrong with that. Oh, I see what you did. You extruded a specific distance in one direction and then a specific distance in the other direction and divided it by 2. You could use extrude midplane and just say 0.375, if I can learn how to type, once. When you hit OK, voila, you get the same outcome. What's neat about this, when I go to the detail drawing of this, see now it turns into hot pink. Why? Because that dimension no longer really exists. So whenever you see a hot pink looking dimension on your detail drawing, that's what that means. But now do you see how 3/8 appears? That's why. That's why that happens. So that's a neat thing to notice. Okay? Now if I pull my dimension up high, these two will fight each other, so I can drag my arrows out a little bit. They still fight each other. If I drag this up a little bit, drag this down a little bit, my dimension, they still fight each other. So what can I do? See how my arrows on the inside? Wouldn't it be nice if I could just kick them outside? Okay, so if I double click on them, there's a change arrowhead. That's not what I want. If I click over here, if I click on this side, that's the arrow type. If I click out here, that's nothing. That's moving it. Well, when I do a right mouse button, I have options. And it says, see how it says arrowheads inside? If I uncheck that, the arrowheads pop outside. That's how I can deal with it. Now these two don't fight each other. I do want to drag my dimensions off the part. Ooh. Okay, you see that? The reason that exists, the only reason that exists is over here in model, I need to roll this puppy down. I had it suppressed. Now when I hit save, and I go to part drawing, oh, it's gone. Isn't that beautiful? And my hole's back too. It's interesting how your model is affecting the detail drawing. When you go back and forth, the two interact with each other. That's what I'm trying to show you, but with what I'm doing. I'm just trying to show you how the two work with each other. This guy is too far out, so I'm going to drag this guy in. That looks good. Let's see what else. This is fine, 0.88. It should be 0.875 as far as the real dimension, but 0.88 is how it's displayed. But here's the annoying part. It threw in diameter 0.88. Well, I won't say annoying part. First, let me see how it was built. It was using the hole command. Now, let me see how it was built. If I edit the feature, okay, you gave it a depth of a distance. I'm going to say change it through all instead of a particular distance. Then I'm going to say OK. I'm going to save the change to the model. And then my detail drawing, let's see if it updates. Didn't even seem to blink. Let me hit save again. That particular change didn't seem to affect it, but let me delete that dimension real quick, pick this view, and retrieve model annotations, and see if it affects anything. It left that as 0.88, but I wanted to say through all. Okay, and these guys dropped in here, so I don't want them to drop in here. I want them to drop in here, but the only way for them to drop in that side view is I got to pick that view, right mouse button, and retrieve model dimensions there. When I hit apply and cancel, then they appear on that side. That's the only way they'll appear on that side. This guy also appears on that side, so I have to delete it from there. See that? Now this drawing's starting to get a little crowded, so I think I'm going to have to move my isometric somewhere else. See how easy that is? I still think I can get away with 101, but I'm going to drag my isometric in that corner. Your isometric can be anywhere. The purpose of the isometric is so that you can show them that the drawing is, that it actually has ribs in it. That's the whole purpose of an isometric view. Because this drawing doesn't show what it really is. All right, guys? So the next step is to see how to make the hole that's through say that without you doing the work. The way to do that is to use under feature notes, you pick the hole, pick that element, and that does say diameter 0.88 through. All right? It will say it correctly. Otherwise, it won't. You're not going to be able to get the correct hole configuration on it. Let's see. Any other dimensions on here? It's a full sectional, 2.5. Let's see. So the best way to double check that you've got all your dimensions in, I usually say, is look at the handout, look at the drawing, and then start checking it off, literally, with a marker. 3/8 is here. That's done. 2 is there because it's over there. Should we dimension 2 there, or should it be here? It's okay where it is, only because it's clear what it's dimensioning. But in general, I would always say don't dimension where you can't see what you're dimensioning, as a general rule of thumb. So if I delete them from here and drop them, see, I have to delete them from the one view before I can go to another view and right mouse button and retrieve model annotation. Notice that? Hit apply. See them there? They're there. Now you see how they appear? Does that really matter? Is that a problem if they appear in that manner? As dimensions pointing that way? No. This dimension, though, I do have to eliminate that one. It's okay if it appears in this manner, top to bottom. That's not a horrible thing. This guy shows as a diameter with an arrow. This is acceptable. If you want to change it and you want it to be like leader, no, that adds a leader, but it adds a leader inside of this. So let me remove that. Undo the leader. Options, arrows inside, that just pushes the arrows outside. Arrows inside. This, you're going to end up leaving the way it is, because how is it in the original drawing? When you look at the original drawing, how is it in there? If we roll this up, it is like that. When I edit that sketch, how is it in the original drawing? That's how it's shown in the original drawing. So whatever you do in the original drawing naturally wants to stay the same here. Oh, I forgot. Let me put, I suppressed everything. Let me unsuppress everything. Sorry. Save it. Then the other drawing should update and not be so. It's still upset with me. See, this isn't attached to the real model because I added it as a whole. That's the only issue. I wish they would fix that. When they retrieve the model annotation, it should carry over that it's a through hole and all that other stuff, and it does not. That I don't like. It's still not fixed. Come on. There we go. The center line does get extremely long. I'm not sure why. These are fine. I'll drag these out a bit. Now you're going to find out when you have these dimensions, they snap out to very specific spots. Have you noticed that yet? If you play with it a little bit, you'll find out that ooh, I want to stop here. That's still too close. How about here? See that? It wants to stop naturally at different spots. Those positions are directly correlated with drafting standards. This guy, I'm going to drag this down just a little bit. There we go. Put this over here. Put this over here. Okay, see that? Try to line them a little bit. So it looks neat. This dimension, make sure it's not inside the parts. You're going to have to drag the nodes out. Okay, make sure it's reasonably away. About the general rule of thumb that we follow when it comes to hand drawings is 1/2 inch for the first dimension from the part, and every other dimension is 5/8 of an inch away. Those settings could be incorporated here in this software by going over to Manage. I'm going to hit Save before I continue on for this action. When you go to Manage, Styles Editor is where you would go. Under Styles Editor are all the styles. I mean everything. Everything you could think of is under Styles Editor. In our case, we want to change the dimensions. To be specific, ANSI. In here, you can say that the default precision is to 2 decimal place, or maybe if your company is at a standard of 4, which is pretty precise, then you would have 4. Get it? 2 is fine for our purposes. Display trailing zeros. Displaying trailing zeros is this, 2.50. See that? Trailing zeros is okay. If I turn this off, save and close, watch what happens to these 2 dimensions. Just watch what happens to these 2. Right up here. I unchecked trailing zeros. Trailing zeros are the zeros at the end. When I hit save and close, did you see they disappeared? By the way, doing that changes the tolerance of those two dimensions. So it's not, oh, it looks better. Stop. If your drawing needs to be to 2 decimal places on tolerance, you have to show 2 decimal places. So you go back to Styles Editor and you stop thinking fashion. Start thinking, what are my tolerances? Trailing zeros need to be there. Okay? If I hit save and close, boom, they're back. Okay? You want your trailing zeros. Going back to Styles Editor, because that's where your tolerances come in. That's this. Alternate units is when you have the metric system and you need to show both dual dimensions because your customer might be from another country. Okay? That's where that comes in. Display means, my favorite section. Those of you in a different class, when you're doing my engineering graphics class, I have a chart that I made for you that covers all of this. And that chart idea came from this when I was in here. Dimension A is the extension past your dimension line. Instead of 1/8 of an inch, that should be 0.0625, a 1/16 of an inch. Dimension B is offset from the object. That should be a 1/8 of an inch, 0.125. The gap, dimension E, how far away is that first dimension? 1/2 an inch. How far away is the second dimension and the stacking of others? 3/8 of an inch. Gap. The gap is how much of a gap between the dimension and your dimension line. That I leave alone. It's okay. Next. Oh, for those of you that like to save a little bit on, if you're cheap like me, don't use filled arrows. You use open arrows. I'm going to say switch to open arrows. Because when you print these drawings out, it uses less toner. Yes, I am cheap. So open arrows is the one you want. Flared is okay. I mean, there's all kinds of arrows. You notice this? And then oblique. Oblique is architectural. We use the little hatch. It's just two of you who are blended, right? Architectural mixed. Have you seen them with the hatch or most of them with arrows? Both ways? Both ways, exactly. So the two most common that I see, open for toner reasons and oblique. And when I did architectural drawings, I love doing oblique. And to be honest, I wish I could always do it because all it is a little slash. It's so much easier to dimension. But open is the one we'll use. The size is fine. I'm not too hung up on that. Text. You want your text to be 1/8 of an inch tall. 0.125. That's the general rule of thumb. Angle dimensions are fine. We usually don't mess with those. Prefixes and suffixes, maybe you want something to always say that, be there like typical, but you don't want the word typical on every dimension, so you don't put it in here. Tolerances, if you have any, you'll have to identify them. Like if you have a dimension that has a max and min tolerance, this is where to put it in. If you want the whole family to have a tolerance. Options. Arrowhead placement. The default is inside. You can say outside. You have a whole bunch of options. See that? I usually say you for most of these, you tweak them at each time you drop them in. Like the one where we have to pull the dimensions out, the arrows out. You don't make it a standard to have dimensions, arrows out. Notes and leaders, if you have any. Generally speaking, you want it to say through. Things like that. How do you want it to be phrased? And that's it. When you hit save and close, it updates everything except the dimensions that exist. The gap is updated, but not their physical location. Okay, you have to retweak it just a little bit so it jumps into its new spot. Okay, the dimensions are just a hair bigger. They were almost 1/8 of an inch already. So, and that's it. When you're done with this thing, you're going to do file, you're going to do print, and this you haven't done before. When you print, current sheet, scale, never pick best fit, please. Never pick best fit. You pick one-to-one. Okay? Preview, I always tell you to preview before you print. That way you know what it's going to look like. Never just print blindly. What I do recommend is that you do print, of all things, print to PDF. So you have a digital copy of what you've done. Okay? You can email me that copy, but you're going to give me a hard copy. The email is cover your anatomy email, so you know you gave it to me. Because when I come back to you and say I gave you a 0, and you'll be like, oh, but I gave it to you. And I'll be like, yeah, I misplaced it. But I have the email, so you're fine. Does that make sense? Because I would like to grade it immediately and hand it right back to you for corrections. I don't want to delay because I only see you once a week. So if I could edit it in class, correct it in class and hand it back to you, I'd rather do that. And that's best done if you just print it and hand it to me. Because if you email it to me, I'll look at it at midnight. That's not going to help. But you do want to create a PDF for yourself. The other reason you want the PDF files is when you want to show this to a potential employer, current or future. You want to bring it to your review. What if you don't have Inventor 2019 on your computer anymore? Holy cannoli. You want to know how many students have come back to me later on, 2 semesters later, say, well, my license is expired and blah, blah, blah. Can I open these up in your lab? I'm like, sure, go right ahead. That doesn't bother me one bit. But wouldn't it be nice if you didn't have to do that? So if you save a PDF file of all the work that you do, then you have a PDF file that can be always opened no matter whether or not you have access to the software. Cool? That is why I want you to PDF it. So that way you can have a digital record that you could do something with. So Microsoft PDF, all of these. What is this one, 9 of 24? I forgot. Oh, this one's 1 of 24. I feel like I'm in a Star Trek episode. No. So now that one's done. Cool? And then you can print one. And there you go. It needs to look neat and organized. 1/8-inch tall lettering. I'm not going to get too hung up on too many things, but I do want this 1/8-inch gap. I need to see a clear distinction, a clear spacing. Like this one's not clear. Why? Because the dimension is in the wrong. See how the node is inside? You got to pull that node out. See down here? It's touching the part, so it's blending. You got to pull the node out. You got to pop it out. Same problem. Oh no, this one's not the same problem. This one's just really close. There's not much you can do about that one. You probably could drag this out a little bit, but I don't think you can. Yeah, that one is 1/8 of an inch away, but it's a small diameter. It's not it's a large diameter, not a small one. So it's hard to see that separation. So that one's okay. But you need to see these gaps on any of the linear dimensions. And that's it. I don't know if this is 100% finished, to be honest. There's the tagging, section AA. There's the AA. This is an inch drawing, so that's why the section view looks the way it does. Cool? That's it. Question? Before I cut the video and do the next one? Good? All right. So I'm going to end this video. Water myself.